Audio! Oh no, the legally required thing is levels. Yeah, my clock says we have like 10 seconds to go. So Kristof just asked me, and I forgot to mention it in the intro session, because of the difficulty in having questions while a speaker is going and their flow, we are not going to take questions during our sessions, and instead we lay down 35 minutes after the talk. This allows more people to be involved in the dialogue, and it hopefully will make the questions better. So if you have questions, just like make a note of them and then catch the speaker afterwards, and I'm sure they'll be really happy to talk about what they've been doing. So this is our first talk of the day. We have Kristof Provost talking about network stack testing. Kristof is the maintainer of the PF firewall in FreeBSD, and he's done a ton of stuff in networking and test automation. And his work has really raised the quality of the network stack of FreeBSD. And I'm really glad that he decided to join us today. And I will hand over audio to Kristof, hopefully.
Well, let's give this a try. Shout if you can't hear me. Okay, no shouting, so I'm going to assume that you can all hear me. Welcome to Belgium. As you can see behind me, it's a lovely day. And I'm here, Tom already stole all of my thunder, not just the first slide, but also the second one. So let's jump straight into it. Oh, there we go, clicking works. I'm a FreeBSD committer. I've been maintaining PF in FreeBSD for, a while now. So if it's broken, I'm just going to blame the last guy. Professionally, I tend to do a lot of embedded software projects, and I typically fall into video or networking projects. Lately, I've been having a lot of fun doing RISC-V things. I would totally recommend that you all run out and go buy a RISC-V board and play with it. The problem is that there's not a lot of RISC-V hardware out there just yet. One of my customers is working on fixing that, and we're all waiting for them to deliver hardware, because I would really like more people to have RISC-V hardware. Moving on to more interesting things than me. What's this PF thing? PF stands for packet filter, which is the most inspired name for a firewall I have ever seen. We stole, definitely imported this from OpenBSD. When I say we, I mean FreeBSD. This was some time ago. In that time, the two have diverged somewhat. The OpenBSD people have changed the syntax. They've added a whole bunch of new features. I have not listed that on my slides because I don't want to admit that OpenBSD do nice things as well. Just forget I said that. There are some shiny things in FreeBSD that the OpenBSD people don't have. One of which is work that was done by someone else to make it somewhat more multi-core scalable. So it means that assuming that you have a multi-core computer, and well, who doesn't? You get them with your breakfast cereal these days. You will get better throughput out of PF on FreeBSD than you would on OpenBSD. One other shiny feature that we have is VNet, and quite a lot of the rest of this talk will be about VNet because it enables the network testing in FreeBSD. Minor spoiler for the rest of it. So as Tom said, I've been doing a lot of PF maintenance work, mostly fixing random bugs. One of the bigger features I did was to teach it about IPv6 fragmentation, because I'd grown tired of PF not understanding that, which gave you the amusing choice between you either drop all IPv6 fragments and then your network doesn't work very well, or you accept all IPv6 fragments and then your firewall can be trivially bypassed. That has long since been fixed, which leads us to the obvious next question of, what have you done for us lately? And one of the most recent projects I've done was generously sponsored by the FreeBSD Foundation, where I did a locking rework on the bridge code. Bridge code so you can turn your very expensive server into a terrible switch. well, a SlowSwitch. It has some amusing features, and it is actually really useful if you run virtual machines or a bunch of other setups. And that is a talk all unto itself. But the very short summary is that our bridge code had one mutex. So you enter the bridge code, you take the lock, you process the packets, you release the lock, and you continue, which is fine if you only have the one core. But if you've got, 10, 20, 40 cores, which, not terribly expensive hardware has that these days, that means that you have one core processing a packet and the other 39 sit around twiddling their thumbs, all the while you get thousands and thousands more packets arriving. So I reworked that. I'm not going to go into any detail about that, but we got a slight performance improvement out of that. I've not heard any complaints about it because, a speed up of about 5x in certain circumstances. In other circumstances, you can get more. There's a write-up about this in the FreeBSD journal. A slight side note here, the FreeBSD journal is not only amazing, it's full of great articles, not so much the one I wrote, but the ones that people like Tom write for the journal are really good. And the FreeBSD journal is free. You can follow this link, or you can just use your favorite search engine for FreeBSD journal, and you can read a whole bunch of back issues. So, I recommend that. Go read. Slightly more on topic, automated testing. Why is automated testing a good thing? Well, because testing can be boring work, and testing is useful if you want to know if things actually work. It's also occasionally useful to have a test case of, I'm trying to build this particularly complicated setup and I don't know if it will actually work. So I'll write a test and see if it works. It's also good to prevent regressions, and I have a few examples of before and after for the automated tests in FreeBSD. And it's also, and this is from personal experience, really, really useful to be able to sanity check when you make changes. We've all made changes to code and gone, oh, this is obvious, this is definitely correct. And if you have easy tests to run, you might be inclined to, run them. And then occasionally you will discover that this obvious change that is obviously correct and definitely should just be committed isn't actually correct, or changes test behavior, which is an indication that you need to take a bit more time to look at it in some detail. I have examples of regressions, not coincidentally about IPv6 fragmentation. The first regression happened in December of 2016 when new IPv6 fastpath code was introduced, and this broke PF's fragment reassembly code. And it took 9 months for us to discover this. So that was 9 months that code was broken, which is distinctly suboptimal. The second time something like this happened, this was in August of 2018. A fix for a security issue accidentally broke IPv6 reassembly, and this was caught by the tests pretty much immediately. It took 2 weeks to fix, but that was, well, because I'm a lazy bastard and I didn't feel like looking at it at that time. That bug is a story unto itself. It was a really amusing bug that went away when you started probing it. So what do we want out of tests? Well, we want them to be easy to write because, as I've mentioned, I'm lazy. We want them to be easy to run so that people run them before they make changes. We also want them to be fast. And definitely that last, well, most of those are difficult to achieve when you do the traditional approach for network testing, be that firewall, bridging code, general network stack, all of it. How would you typically approach this? You take a bunch of machines, let's say a machine to send packets, a machine that you are testing that will process the packets, and a machine to receive your packets. And then your problem starts. How do you get the codes that you want to test, your operating system, to run on the test machine? Well, one possible way of doing this is you netboot the test machine. But netbooting your test machine when you're trying to test a firewall gets tricky. Okay, let's test this firewall scenario where we drop all traffic, and oops, root file system just went away because that's network mounted. It's possible, but you need to take that into account with all of your tests. Those are typically also brittle setups. And you can't just SSH into the remote machine because you generate more traffic that will affect your test, and it's a huge pain. You can get a serial port, or you can IPMI a serial over LAN or whatever, and that works. But that means that sooner or later you're going to be writing expect codes, and you will lose the will to live. These days, you can trivially run that in virtual machines, and that makes life a good bit better because it's easier to create a virtual machine with the code that you want to test. You don't need a whole bunch of hardware, but you're still writing expect code to tell it what to do. It's possible. A couple of years ago, a GSOC student tried this approach and got it to work somewhat, but it's slow and it's annoying and it's got all of these moving parts in it. And this wouldn't be an interesting talk if I didn't have a slide that went, there is a better way. So here's a slide with, there is a better way. FreeBSD has what we call VNet or VIMAGE, and we use the terms basically interchangeably. And it's essentially a virtual network stack. They're associated with our jails, and think of jails as chroot. Well, I used to explain them as chroot on steroids. Jails are containers. They're containers, and they can have their own network stack. And we have enabled the VNet feature since 12.0. For those of you not up to date with FreeBSD releases, 12.1 is the current release. So 12.0 is not that long ago. And our firewalls support this notion. So you can configure PF inside a jail and have your own firewall configuration in a jail. Or you can create a bridge in your jail and bridge whatever interfaces you have added to this jail. And well, I've added this note that it's not just PF, our other firewalls. Yes, we have 3 firewalls. I'm sure there's a good reason for that. I've just not been told what it is. They support this. You can configure whatever firewall you like inside your jail, and this is hugely convenient, and it is extremely nice when you're testing, as we'll see later on. Slightly more specific now, how do we do this? Well, it's surprisingly easy to create a jail with its own IP stack because this is the command that does it. You create a jail, -c to create it, you give it a name, and I've named it Alcatraz because I just think that's funny. You say that you want a VNet jail by using the VNet keywords, and then persist makes the jail persist even if there are no processes in it, which is for classical jails when you're not doing network connectivity, not terribly useful. But when you have a jail that's, say, a firewall, you don't necessarily need processes running in it. Now, of course, this jail doesn't have networking connectivity. Despite having its own network stack, it doesn't have any interfaces, it doesn't have IP configuration. So how do we do that? Turns out that's also not difficult. One thing you can, often you will use this with e-pairs. E-pairs are another FreeBSD feature. Think of e-pairs as 2 network cards with a cable between them. So when you create an e-pair with sudo ifconfig e-pair create, yes, our commands are truly opaque and difficult to understand. You will get 2 e-pair interfaces, e-pair 0a, e-pair 0b. Obviously, if you create another one, it'll be 1a, 1b. And those 2 are linked. If you send a packet through e-pair interface e-pair 0a, it will arrive at e-pair 0b, and obviously vice versa. So if we want to communicate with a jail that has such an interface, we'll give our interface that we keep on the host an IP address, and then we can create a jail. Sudo jail-c, name is Alcatraz, VNet persist, VNet.interface is e-pair 0b. And then e-pair 0b will disappear from the host system, but you will have a jail that has an IP that has that interface in it. Or you can create the jail as we saw on the previous slide and then just go ifconfig e-pair 0b VNet Alcatraz, which moves interface e-pair 0b to the Alcatraz VNet. As I said, very opaque command syntax. And then you can execute a command inside the jail. Note the complete lack of interactivity required. Expect no sign of expect. We just go jexec Alcatraz. So we execute the command in the Alcatraz jail, ifconfig epair0b. Here's an IP address. Once that's done, you can communicate. Just send a ping, one ping only, because and then that works. And that's it. That's all that you need to do to set up a jail with its own IP stack. Now, obviously, this one isn't terribly useful, although this tests a surprising amount of code. Having recently done some bridge work, the example that I've got for our test code is for the bridge. This is essentially just boilerplate startup code. It's not terribly interesting. What it says is we are declaring a test case, bridge transmit IPv4 unicast. So no prizes for guessing what we're going to be doing in this test. There's a head function which you just set a description and point out that you need to be root to run this test. And here's the test body. And I didn't cheat. This is literally the entire body of the test as it lives in the FreeBSD source tree right now. This doesn't test everything about the bridge, of course, but it does test a fair bit of functionality. Walking through that very briefly, we initialize the VNet. It's just a helper function. In essence, what it does is make sure that the VNet feature is enabled on this kernel, because otherwise you can't run this test. We create two e-pairs. We don't actually use, well, we don't directly do ifconfig epair create here. What the VNet mk epair function does is it keeps a list of the interfaces that we've created, so that when we clean up this test, we remember to delete all of these network interfaces. Same thing with the VNet mk jail. We create the jail and we remember that we've created, the jail, so that we remember to delete it at the end of the test. So we create two interfaces, we create two jails, we jexec Alcatraz ifconfig epair Alcatraz blah blah blah. Essentially, we assign IP addresses in the jails, and then we create a bridge on the host system. We set the bridge up, we set the epair interfaces that we're going to add to the bridge up, and then we add those interfaces to the bridge as well. Could do that in fewer lines, but this is clearer. So what we end up with is a bridge on the host that has two interfaces in it. Those interfaces each go to one jail, and that means that in theory those jails can now send packets to each other. So we check this with the ATF check function. ATF, by the way, is the automated testing framework which we liberated from NetBSD. So we expect an exit code of 0. We ignore the output. We jexec, so we execute in Alcatraz the command ping-c 3 packets, timeout of 1 second, to the IP address of the other jail. And then for completeness, we test traffic in the other direction as well, because we might as well. What have we demonstrated with this? We can create bridges. We can assign them to VNets. We can exchange traffic over them. And then implicitly, well, here, in fact, when we clean up the test, this VNet cleanup function will automatically delete all of the interfaces, delete all of the bridges. So we've demonstrated that we can create a bridge, we can add interfaces to it, and we can send traffic over it. Now, that's not all of the functionality in the bridge. This doesn't test every single possible scenario, but it tests a surprising amount of them. While I was doing the locking rework, quite a lot of panics happened during this test. So now to execute this, we use Cua to run this test, and this command just runs the one test, ifbridge test bridge transmits IPv4 unicast test, and this test takes 2.6 seconds. Most of which is the time required to actually send the ping messages. And I think you'll agree that 2.6 seconds for a network test, create the jails, configure them, send ping messages, and then clean everything up again in 2.6 seconds. I think you'll agree that that is suitably fast, which means that it's very easy and very convenient that, oh, I've made a change, let's just really quickly run through these tests. And I found that Doing reviews of other people's code, usually the first thing I do is, okay, apply the patch, build it, reboot, run these tests. And quite, well, not often, but quite commonly, these tests will discover panics, they will discover broken functionality. And most people, once you've pointed out to them 3 or 4 times that, oh, by the way, the tests break if you do this, they will decide that, maybe I should run these tests because, they find all of these bugs. Where can you find them? In a FreeBSD system that has a source tree checked out, source trees live traditionally under user source. The test subdirectory contains the tests. Yeah, I know it's very opaque, right, where we organize all of this. Sysnet has some networking tests. Sysnet pfill pf has some tests for pf. Net pfill common has tests that are common for all 3 firewalls. That's a project, a GSOC project that Tom mentored last year, and the student did pretty good work coming up with a test framework that makes it reasonably easy to write tests for all 3 firewalls. When they get installed to users test, and essentially the directory structure remains constant. You can just go to users test and execute all of the tests, or you can go to a specific subdirectory and execute a specific subset. Generally, when you make changes to the network stack, there's not much point in running the file system tests. Generally. So now that we've gone over, how these tests can work and where you can find them, why would you want to write tests? Well, I've already mentioned you can prototype setups in this. Another really good reason is when you decide that you have a particular use case that you really like, be it bridging, firewall configuration, whatever, you want to make sure that those developers don't accidentally break it. So submit a test case. If the test is even vaguely reasonable, it will get included in the CI tests that run very frequently. And we will discover when we accidentally break your use case. Another really good reason is when you want to file a bug report or when you have a pet bug that needs to be fixed. Because giving me a test, and me specifically if you have a PF bug, but for other networking features for other people, I'm sure they will be delighted to get test code as well. It turns out that quite often when I get a PF bug, I spend a lot more time on actually trying to reproduce the bug, understanding your test setup, your configuration, understanding the conditions required to actually provoke the bug. How do I detect the bug? I tend to spend more time on that than on actually fixing the bug. Quite often people forget to give all of the relevant information. Sometimes they'll give the firewall configuration, but they'll forget to mention that they've changed some other system settings that also impact firewall behavior, and then I can't reproduce the bug. If you give me a test case, at least half of the work just goes away. It's done. I don't have to do it anymore. So that makes it a lot easier for me to actually fix your bug. And if you give me a test, it's often easier for me to understand what the problem is than if you just give me a patch. Because if you give me a patch, I still have to go and understand what the problem is. And then I still have to write a test. And as we've covered extensively, I'm really lazy. So please do my work for me. Write the test. You wouldn't be the first person to write a test. I think the first person to follow up on the test framework I set up for PF. So PF were the first tests to make use of this, but the second set were for IPsec. Olivier was tired of IPsec being broken all the time, so he wrote tests. And now IPsec is not broken because people notice when it breaks. And it got broken again fairly recently because people were doing changes to the crypto framework and there was fallout on the IPsec tests. And it only took a couple of days to notice and get it fixed. We all know that the developers are more inclined to fix bugs if you report them soon after they do their commit, as opposed to 6 months to a year later when they've completely forgotten how that feature worked. We now also have tests for the other firewalls, for VLANs, for the TUN interface, for the bridge. We've got multipath testing. We've got IPv6 tests. We by no means have full coverage of all possible features of the network stack, but my experience has been has repeatedly been that even very trivial tests will find bugs. And you only need to write tests for about 10% of the function. Well, it's 10% effort, 90% result. It's not a lot of effort to write fairly straightforward tests, but they find a lot of edge cases and bugs. So because we'll cover questions later, I can only I can point you at contact information. I'll hang out on the campsite a bit for questions later. But here's my email address and Twitter handle where you can find me and shoot questions at me. And to conclude, I feel like I need to point at a deeply profound quote by a really intelligent person that reinforces my point. Unfortunately, I didn't find any, so you're going to have to do with this terrible quote by this random idiot. But seriously, write tests. Tests are an incredibly good idea. They are incredibly useful. And these networking tests with FreeBSD's VNet feature are actually really, really easy to write. Amusing anecdote there, those VLAN tests happened because I was trying to convince another FreeBSD developer to write tests for it. And I said, you know what, we're here. Why don't I show you how you can write tests by writing a quick VLAN test? And it took me longer than I expected because about 3 minutes into writing the test, I had found the kernel panic. So write tests, they're really useful. And I think that puts me at the end of my time slot. So I will try to figure out how to jump into the campsite and hand you back to Tom. Tom, are you there?
Okay, thank you, Kristof. This is normally where there'd be like thunderous applause. That doesn't really work with individual microphones.